This short tutorial is just going to go through how to use the phase diagram to work out how much nickel and copper is in the liquid and solid solution at different temperatures. So the quick thing we need to remember about these diagrams is that we have a diagram which is talking about percent weight of nickel. And so we understand that that goes from 0 up to 100% on this x-axis. And this is our temperature obviously going up there. Okay, but what we need to remember is that this diagram, because it is a phase diagram, is also representing that there's a copper component which goes from 0 and goes down to 100% over here, all right, which is not shown on the diagram. And so for this reason, the best way to look at these diagrams is to forget about the copper altogether. So that's why I've deleted these copper elements altogether and just look at it from a nickel's perspective. And then once you do that, it's much easier to get the copper sorted out at the very end. So looking at this, what I'm going to get going with is showing you how to calculate the different percentages of nickel in this solution. And the first thing you need to understand is that we see in the solid state at point A, everything is liquid. So that means there's no nickel and no copper in the solid state because it's all liquid. And by the same token, we understand that if we look down here at this point E, everything is solid. There's no liquid present, which is why there's no nickel or copper in that state, because there is no liquid. All right, so those two are simple and easy ones to sort out with. What we then move down to is this next point B over here. And this is represented by these tiny little bits of solid, which are represented here. But most of our stuff is still liquid. And at this point we see, well, looking at the liquidus line, if we come down here, about 35% of our liquid solution is nickel. So that's why we look at this nickel, because we're doing a nickel graph. 35% of the liquid, because I'm taking from the liquid line, is nickel. So I write 35 in there. And then if I go across here, I can come down, and by the same reason, looking at the solid line, I can say, well, about 46% of the solid, which is these little dots, is nickel. We're not going to worry about the copper. We're just going to look at the nickel. Nice and easy. Let's go to the next one then. We're going down to point C. We go across and we come down. We say, well, at this point, at this temperature, that's where the line hits the liquidus line. We see over here about 32% of the liquid is nickel. So that means all this yellow stuff over here, we've got about 32% nickel in the liquid. And we come across here and down, and we see about 43% of these solid bits have got nickel in them, which is why you see 43 nickel over here. And then we go further again, we go to point D, go across and down, and we see that there's now only about 24% in that little bit of liquid that's left is nickel, and 35% of the solid is nickel. So again, we're just focusing on the nickel. And then obviously, as I mentioned, when we get to that full solid state, we don't have any liquid left, which is why there's none. But we do still have that composition of 35% nickel in that particular composition. So once we've got that done, then it's nice and easy, because we can simply say, well, out of the solid, if 46% of that solid is nickel, well, then the rest has to be our copper. And so you just subtract 100 from 46, 54%, 57% has to be copper, 65% has to be copper, 65% copper over there. So we don't even need to look at the diagram at all. We can work this straight out from just putting the table numbers in there and subtracting 100. And by the same token, we can do the same over here, 24, 32, 35 minus 100. So it's pretty simple to do the copper once we've worked out all the nickel, which is why I'm asking you to just do it using just the nickel off the diagram first. So hopefully you find that helpful.